Welcome back to Mathematics for Electronics, and today we're going to be talking about the decibel. So the big thing to think about here is the decibel represents a real-world application of logarithms and exponential functions. In other words, all that fun stuff that you learned in Chapter 20, now you get to see it in Chapter 21, because Chapter 21 deals with the decibel. So first off, let's talk about the decibel. The idea that we're going to investigate the power in decibels. So let's take a look at some explanations of it. So first off, power in decibels, right? Decibels itself, it's simply a unit. It's a practical unit for measuring what the ear hears. And typically, this is how you would represent a quantity of decibels, right? The unit is little d, capital B. And what decibels do is it indicates the performance of all types of electronic devices and circuits, all right? So that's the decibel. And then specifically what we're going to look at is calculating the power in decibels. And so power, definitely covered that concept in the past, right? So basically the new thing here in Chapter 21 is your decibel. But power, if you think back, what is the unit of power? Watts, right? And then the other thing that we've learned about power from past chapters is there's a formula to calculate power, and actually you can manipulate that formula and basically, dependent upon what you're given, run with it and come out with this quantity of watts, in other words, power. So let's look at those formulas. All right, so first off, of course, our unit, all right, is watts. All right, this is a little blast from the past. Capital W. So anytime you see some quantity of capital W, that's of course watts. And then now let's talk about our power formulas. All right, one power formula that we've played with in the past is I squared R. Right, I squared R. In other words, I, that's your intensity of electron flow or current, square that and then multiply it by your resistance. So that's one way, right? If someone gives you current and someone gives you resistance, no problem, square your current, multiply by resistance, and bam, there you've got your power. Or another way to think about power, right, is if someone gave you the voltage across something, right, you would square your voltage and divide that by resistance. Or last but not least, right, if someone gave you voltage and someone gave you current, you could also solve for power. So three ways, right? If you know current and resistance, right? So given these values, right, these concepts, so current, of course, what's the unit of current? Amps. What's the unit of resistance? Ohms. So that's real important. You may not be told this is current, but you might be told, 7 milliamps, right? And then you would say, amps, that's my current. Or you might be given 60 ohms. That's my resistance. So, don't feel like I have to see the word current and resistance in the problem. If you're given quantities of current or resistance, then you're going to run with this formula. And then likewise, we've got this formula, which involves, as we mentioned, voltage. The unit, of course, is volts, and resistance, right? And we know those units are ohms, right? And then last but not least, if you're given voltage, right, some quantity of volts, right, and current. Okay, so it's just real important to not only identify the fact that, it's voltage or current, but also what's the units, right? If given some quantity of volts, given some quantity of ohms, now I can solve for power, so on and so forth. And the other thing to point out is that these three formulas, right, I squared R, V squared divided by R, V times I, you really only need to know one of these formulas and Ohm's law. So let's think about what Ohm's law is, right? Voltage equals IR, right? That's your Ohm's law. So how can knowing Ohm's law and just one of these power formulas yield the rest? Let me show you. For example, let's say all you knew is this formula. Power equals I squared R. All right? What you can do is say, okay, well, let me get in here, and in my Ohm's law formula, I'm going to go ahead and solve for I, right? Solve for I. So in order to solve for I, we're going to need to isolate I. So we're going to divide both sides by R. So now we've got I equals voltage divided by resistance. Now we're going to take this I, and guess what we're going to do? Substitute, right, in here in our power formula. So power equals, pull out I, and in its place, V divided by R squared times R. What's this equal? Right? Well, so the idea here is just continue the fun. V squared R squared, right? That's what's going on inside your parentheses. So we simply squared it, right? So that's distributing your exponent, and multiply that, of course, by R. So now you see something's going to cancel, all right? This R is going to cancel with one of these R's. So basically what you have is V squared divided by R. And fingers crossed, if we look back to our original, let's kind of move back here to our original layout of our power formulas. There it is. V squared divided by R is simply another way of solving for power, utilizing, of course, Ohm's law. Okay, and then this last one, right? In other words, how could you derive this guy using Ohm's law and just one of your power formulas? Well, let's see. All right, so we've got here I squared R. Let's go ahead and take our Ohm's law, and instead of solving for I, let's solve for R. Let's do it. All right, so we've got V equals I times R. Solve for R, therefore you're going to isolate R. All right, so we've got R equals V divided by I. Let's come back to our original power formula. Original power formula, power equals, make this look a little more like a equals, there we go. All right, so here's that original power formula. What I'm going to do is I'm going to take R that I've solved for from Ohm's law, and I'm going to apply the substitution technique. Check this out. All right, so I have I squared. I'm going to pull out R, and in its place, I'm going to put V divided by I. Does that make sense? Right? Literally pull R out, and in its place, V divided by I. Right? And then now you see that I down below cancels with one of the I's up top. And here you have, right, I, V. That's your power. Power can also be solved if you know I, your intensity of electron flow, and of course your voltage, right, which is just up here, right? If you know these two, you're set, right? Voltage is, of course, there we go. Let's see if we can get that. Voltage is, of course, in volts, and current, that's, of course, in amps. So knowing volts, knowing amps, bam, you've got power. So with that said, right, basically up to this point, it's been a little review, right, because we know our power formulas, all that good stuff. So the next thing we're going to look at is bringing in this concept of decibels. In other words, what's new about chapter 21 is they're going to bring in this real-world concept of decibels and then link it to what you already understand about power. So let's see how that happens, all right? So we've got something called NdB. NdB. dB, you've seen that before, haven't you? This is what? The unit for decibels, all right? So NdB equals 10 times the log, to take a look. This is chapter 20, right? This is a common logarithm, right? So 10 times a log of P out divided by P in. In other words, your output power divided by your input power. All right, so there's some things to point out about this formula since it is very new to us. I'm just going to put this up so you can see a little higher. All right, so your NDB completely depends. If your value is positive, this would be considered a gain, or if your NDB is negative, shouldn't surprise you, right? It's considered to be a loss in decibels. And of course, decibels, the unit, little d, capital B. Okay, but what's kind of nice is in the formula to solve for decibels, you are reminded what the heck is the unit for decibels. So that's pretty cool, all right? So my hope is if there's one unit you're not going to forget, it's decibels, because there it is. There it is, little d, capital B. All right, so it's a cool relationship here. So the gain or loss in decibels is equivalent to 10 times the common log power out divided by power in. Excellent. So if you were straight up given the output power and the input power, we simply divide, pop that into your calculator, right? Your best friend, find out what's the log of it, multiply by 10, bam. Pretty straightforward, right? But of course, your book involves so much more fun than just, popping in these values and cranking it out. In other words, what's going to happen in chapter 21 is you're going to have to solve for your output power and solve for your input power. So let's see how that might happen. All right, so our first problem, what we're going to do is we're going to be determining, all right, typical problem from chapter 21, I might add, right? We're going to determine the voltage dropped. All right, voltage dropped. I'm going to go through each one of basically these problems, and every word actually is pretty critical. So we'll just go through this and make sure you're very comfortable with these problems. All right, so let's determine the voltage dropped across a 4 ohm load when a microphone this is important, at the input, very important, right? So these are key words. Again, right, we're going to walk through, so, right, you're not going to get lost with these word problems, right? So when a microphone at the input develops 6 millivolts across 600 ohms. All right, and then the last little bit of information that we're given about this problem, note gain of your amplifier is a positive 36.50 decibels. All right, so this is the last bit of information, which is very important, right? Is that the gain of our amplifier is a positive 36.5 decibels. So first off, you want to ask yourself, all right, what's your goal? Okay, so the goal here is, of course, the voltage. And then the next thing you're going to want to ask yourself, right, is what do you know, right? So in other words, your givens. Okay, and then this is the fun part. It's almost like you're going to be a Sherlock, right? And this is a little mystery, right? And so given, this little mystery, we're going to get in here, we're going to figure out, well, okay, I realize I have a resistor, but what kind of resistor is this, right? I've got a 4 ohm resistor, and I happen to have, it looks like I've got a 600 ohm resistor, right? So 2 types of resistors, right? So I'm going to go ahead and put R. But specifically, we need to understand who is the output resistor and who is the input resistor. What do you mean output, input? Let me just bring you on back. All right, remember this formula? Right up here. This is our brand spanking new formula. New for chapter 21. Notice right within the common log function, you have an output power divided by input power. So for your chapter 21 fun, everything needs to be consolidated in either an output or an input. So not just power, right? But everything that is involved in calculating power. In other words, resistance, and in this case, right, voltage. All right, so things to observe, right? So we have R out that we need to figure out and R in. So based upon this problem, so if you carefully read it, right, let's determine the voltage dropped across a 4 ohm load when the microphone is at the input. All right, microphone at the input develops 6 millivolts. So let me go ahead and note this too. So we have a V. All right, and my hope is, again, I underlined it for a reason. It won't be underlined in your book, but that's the idea, is really look for these words. So it's telling you there's a microphone at the input, and the input we are developing 6 millivolts, right? So that's at the input. I'm going to go ahead and write 6 millivolts. Well, if Vn is 6 millivolts, and we're developing that across a 600 ohm resistor, which resistor do you think 600 ohms is going to fall under? Rn, right? Because when a microphone at the input develops 6 millivolts across, bingo, 600 ohms. And so by process of elimination, if Rn is 600 ohms, then that other resistor must reside at the output. So that's your R out. And of course, the other given, very important, it's a gain, hence positive dB, right? A gain of course, positive 36.50 decibels. And then now, of course, your goal. So I'm just going to go ahead and note that. That's important, right? Dr. Stephen Covey says, keep the end in mind. Got to keep it in mind. This is what's going to drive you to keep your A in this class, right? So your goal is to determine the voltage dropped across a 4 ohm load. Well, if the 4 ohm load is at the output, then V out is your goal. And what's the units of voltage? Volts, right? Volts. So make sure you note that, right? Don't just put question mark. Make sure you put whatever the unit should be. That's going to remind you to write your units down, all right? Because I'm going to be looking for that on the exam. I don't just need to see the correct quantity. I'm looking for the correct units. All right, so now the fun begins. All right, so let's go ahead and think about which power formula. So I'm going to go ahead and just do this first step, right? Which power formula should we use? This should be the next question you need to be asking yourself. Which power formula should we use? All right, so if we know resistance and we know voltage, right? You don't have to go too far back, right there. If we know resistance and we know voltage, then this is the formula that we're about, right, to solve for power. Remember, we have 3 options. Choose the power formula based upon what you're given. That's key. That's why it's imperative that you list your goals. List what you're given and list your goals. That's important too. All right, so let's come on back to our first step. So we are going to use power, right? Power equals V squared divided by R, all right? And so now let's go ahead and think about, well, if we know, right, everything we need for our input power, we can actually go ahead and solve for that, right? So I'm going to just put the little, right, in. So power in is Vn squared divided by Rn, all right? So that's going to be 6, and then of course milli, that's going to be times 10 to the negative, what? 3, very good. Volts, don't forget, the whole thing needs to be squared, because Vn is 6 millivolts. So 6 times 10 to the negative 3 volts squared divided by Rn, that's given to you as straight up pure ohms. So you have pure volts squared divided by pure ohms. All right, and when you work that out, matter of fact, let's work that out together. All right, let me go ahead and clear. All right, so what we're doing is we're taking 6 blue EE, all right, to the negative, oops, let me see, clear that, do that again. All right, so we want 6 millivolts. That's going to be 6 blue EE. There we go. Remember, when you see the E, that's times 10 to the, and then it's waiting for your metric prefix. Negative 3, because we're dealing with 6 millivolts. All right, and let's go ahead and square that. There's your keystroke to square. All right, and actually, let me just do a little back here, delete. All right, let's evaluate first. Back here, delete. Let's just evaluate this, and then we'll square it just so you can see. All right, and then divided by, of course, your Rn straight up, 600 ohms. All right, when you work that out, right, you're going to see it's 6, tiny little bit of watts, right? 6 times 10 to the negative 8 watts. All right, I just want to show you here in case, I just want to make sure you're not missing this, that 6 blue EE, I'm just trying to access that function EE, right, which happens to be a subfunction, so I have to do the blue. When you type that, basically it's just a tiny, right, which is what 6 millivolts is, right? This is it. 6 millivolts is 0.006 volts, right? And then square it, of course, right? And then last but not least, divide it by pure 600. So there's our quantity for power in. In other words, what's the unit for power? All right, this is 6 times 10 to the negative 8 watts. Very good. All right, so let's go back to problem here. All right, so that's going to be 6 times 10 to the negative 8 watts. Excellent. All right, so now, all right, if we could go ahead and let's bring in our NdB formula, right? This is the new concept for, of course, your chapter 21. All right, so it's going to be 10 times the log of power out divided by power in. All right. What do we know? We definitely know this, right? That's going to be, of course, your 36.5 decibels, all right, and it's, of course, positive, times 10 to the log of your output power. That's what we don't know. But we definitely know this, right? Our input power times 6 times 10 to the negative 8. All right, so just want to point out that once we've noted down, right, everything that we know, in other words, remember our given list, okay? All right, we know our decibels, we know our input power thanks to our V squared divided by R formula. Right? Now we're ready to solve for power out. And basically, at this stage of the game, we are back in chapter 20. This is chapter 20, right? Chapter 20 gave you all these groovy exponential functions, logarithmic functions, and then instead of P out, it may have been X, right? Same approach though. What you learned in chapter 20, you're going to apply in chapter 21. Same thing. Okay? What's fun about 21 is this is real world stuff. In other words, this is exactly how you would solve the output power. All right? So that's the fun part, is this is for absolute real world application. But everything you did in 20, learning how to play with exponential functions, learning what all those groovy keys on your best friend, also known as your calculator, did, right? That's going to help you here. All right? So let's jump back in. All right. So what we're going to do now is, of course, let's go ahead and divide both sides by 10. All right, so let's just watch the process. Watch what I'm doing. 36.5 divided by 10. All right, if you're not sure, remember, you've got a best friend. Ask your best friend. 36.5. Right, divided by 10. All right, there it is, 3.65. All right, so 3.65 equals the log of P out. Remember, that's your unknown. That's your x, divided by 6 times 10 to the negative 8. Excellent. All right, so now at this stage of the game, you can think back to all of those cool log functions that you learned. In other words, right, you learned a lot of neat ones, right? If you were dividing, for example, right, you could rewrite this as what? The log of P out minus the log of 6 times 10 to the negative 8. That's 3.65, right? Remember in chapter 20, we looked at all the neat type of, basically ways to mess around with log functions and natural log functions. Remember, it's the same. If you're dividing, right, your numerator, that's first, the log of whatever that is, minus the log of whatever this is the same thing as this. So we're going to go ahead and apply that. The reason why, of course, because we're trying to isolate the log of our output power. That's our diabolical plan. All right, so in order to do that, right, we're going to go ahead and add the log 6 times 10 to the negative 8 to both sides. All right, remember, this is just a number. We're going to go ask our best friend what this crazy number is, because that's all it is a number. All right, so the log of P out is equivalent to 3.65 plus the log of this guy. So let's go ask our best friend. All right, so we already have 3.65 plus the log of 6 blue EE. There we go. To the negative 8. Close those parentheses and evaluate. All right. So now, right, let's go ahead and note that value down, right, negative 3.57. Right, so negative 3.5719. We'll just carry it out 4 places past the decimal. That was what we learned back in chapter 20, right? All right, so now at this stage of the game, this is the fun part, right? We are ready to break in to this logarithm function, right? This common log function. And what do you break into it with? Anti-log, right? That's exactly, just think that if you have a common log function, you break into that log function with your, right, anti-log. Likewise, if you have an ln function, a natural log function, you break into your ln function with anti-ln. Same idea. Let's do it. All right, so we have your anti-log of the log of your output power. What you do to one side of the equation, you must do to the other. So you're going to do the anti-log, negative 3.5719. All right, well, the anti-log of the log, remember that cancels. That's how you break into the function. Out pops your output power. And on this side, you want to think about, well, gosh, the antilog of negative 3.5719, that's the same thing as 10 raised to negative 3.5719. So let's figure what that out is, right? Let's figure it out. In other words, your output power is this guy. Let's go ahead and evaluate that. So if you go back to your best friend, right? So take a look, little blast from the past, right? Your 10 to the x function, that's your anti-log, is literally the subfunction of the log. So you're going to go to the anti-log of your answer. In order to get your answer, if you've got a TI-84, you're just going to go second, and then notice your answer is a subfunction, and then close those parentheses. And if you do it right, you should end up with 2.68 times 10 to the negative 4 watts. What do you mean watts? Let's think about, why is this watts? 2.68 times 10 to the negative 4. It's because we just solved for power, right? The unit for power is watts. But was that the goal? Was that the goal of this problem? No, what's the goal of the problem, right? When in doubt, check it out, right? Your goal was your output voltage. That's what you want, right? Output voltage given this output resistance, right, of 4 ohms. So let's do it. All right, so we know output power. We just calculated it. All right, and we know R out. That was given to us as 4 ohms. Therefore, solve for V out. This is our ultimate goal. All right, let's get that power formula that we're very familiar with. Power out is V out squared divided by R out. So you want to take this formula, don't want to solve for power, don't want to solve for resistance, we know that. We want to solve for voltage. All right, so solving for voltage, what are we going to do? Let me go ahead and rewrite this formula so you can see what is going to happen. Basically, you're going to multiply both sides by R out. Why the heck would you do that? Because now you've got R out times your output power is V out squared. If I want V out all by itself, what are you going to do? Yeah, right? You can take the square root, right, of something squared. What you do to one side, got to do to the other. So anything squared, if you take the square root of anything squared, out, that pops. So you're going to have V out equals the square root of R out, that was 4 ohms, times power out, 2.68 times 10 to the negative 4. Right, notice I'm not writing in the units, right, simply because, right, we know what the units are, but when we're actually crunching this, we're not going to enter units into our best friend. All right, so just for simplicity's sake, right, you'll notice that I leave my units out. But this is important. Got to multiply 4, right, times your 2.68, right, times 10 to the negative 4. And let's go ahead and do that. All right. So that's going to be, actually we already have that there. Let's go times, all right, that's going to be up to times your 4. All right, so that's your voltage, right, times your resistance. Let me show you where we are in the step. So that's 4 times this, and then the last thing we need to do is take the square root. All right, let's find that square root. It's a subfunction, of course. In this case, blue, there's that square root of the answer. Close those parentheses. Whew. All those buttons to get this beautiful number. 0.327. What? What's the units? Right? Remember I was saying we don't type units into our best friend, also known as a calculator. But what is the units? You got to make sure you know that. Right? 0.03. We could round up the 27 to 3. That's fine. This is what's key. Volts, right? So the square root of ohms times watts gets you volts. Right? Very important. Make sure you know the units of what you're about. Bingo. All right? You just solved that awesome problem. All right. So let's go ahead and look at another one. All right? Because I think the more examples you have, the better. All right? Just to get you comfortable. So let's look at this example. All right. Let's start with a brand spanking new page. Here we go. All right. Here we have a ceramic transducer. All right, a ceramic transducer. And we are told that this guy develops 180 millivolts across 15 kiloohm. This is a very important word. Input, right? Resistance. All right, so we've got a ceramic transducer develops 180 millivolts across a 15 kiloohm input. Right, your book doesn't underline it, but I'm trying to draw your attention to that word. Input resistance, all right, of an amplifier. And then we're also told some information about the output. Another important word to pay attention to. The output power developed, right, across an 8 ohm load is 24 watts. And then here comes the goal. Determine the decibel power gain of this amplifier. These are such fun problems. All right. Very cool. So, right, given this problem again, word by word, I really want you to just we're just walking through this. Right now, don't get frustrated if at this stage of the game you're not very familiar with ceramic transducers or how they work. Remember, this class is Math for Electronics. What you're trying to do in this class is just get comfortable with the math behind real-world electronic-related devices. That's it. So what's the math behind it? How do you manipulate the math? And when you get to your courses beyond Math for Electronics, of course, then you're going to get hot and heavy in the theory behind ceramic transducers and amplifiers and all sorts of other fun, groovy things that you're reading about here in Chapter 21. So I don't want you to get stressed out with Chapter 21. I want you to really just kind of go with it and just realize that key words to pick up on: input, output, ohms, and think about ohms. What's that the unit of? Volts. What's that the unit of? Watts, right? That's the idea. Recognize units, recognize input, output, so that you can pull out a formula and make those connections. All right, and of course, for Chapter 21, the brand new concept is gain or loss in decibels, right? So that's that NdB. So you want to start thinking about in a formula, oh, gain or loss, that's what that is. Okay, so don't get stressed out by the actual components that chapter 21 and actually a lot of the book, of Math for Electronics books, they try to slip in real world examples for a reason, right? Which I think is really fun because to me that puts value to the math you're doing. But I just don't want you to get stressed out by, I'm not an expert with ceramic transducers right now. No worries, you will soon. Hang in here, keep up with the class, move on, and then I promise you will get very familiar with these guys. But in the meantime, just step back and realize, units for voltage, units for resistance, units for current, what is that? All right? Units for our new concept, decibels. Oh, little d, capital B. That's what you want to focus on, input, output. All right, so let's jump back in this problem. Okay, so first off, of course, I want you to make a list of your givens. All right, this is so important. All right, in other words, you're consolidating. At this stage, you're taking words and you're transforming them into pieces of formulas. That's really what we're doing, right? So, for example, we have this idea of 180 millivolts. What is that in a formula? Could be a voltage. Sure, that's a good guess. But now you have to ask yourself, what kind of voltage? Right? So let's read, right? It develops 180 millivolts across a 15 kilo ohm input resistance. So input resistance is linked to this voltage. So this must be input voltage. Right, again, remember this is like a Sherlock Holmes mystery, right? If you like mysteries, you're going to love chapter 21 because this is what it's about, right? You're reading your problems and you're saying, let me extract, what is that? That's my input. And then take a look, 15 kilo ohms, what is that in a formula? I think that's resistance. And specifically what kind? Yeah, baby, input, right? They're pretty obvious there. Not too mysterious, right? 15 kilo ohms. And then as you continue, right, it's telling you outputs. Now we're talking about the output, right? Developed across an 8 ohm load. So that's going to mean, right, here's another resistance, but it's going to be output, right, R out. And R out, right, of course, is 8 ohms. And then we're told is 24 watts. So output power, so that's P out, is 24 watts. All right, good stuff. Okay, so now, well, what's our goal? Right, given all this awesome information, what the heck is our goal? Determine the decibel power gain. So that's going to be a positive. We know gain is always positive. Positive N dB. All right, and that's going to be what units? Go ahead and write them. Even though we don't know what the heck our goal is right now, you know that whatever the goal is, on an exam, you want to make sure you write those decibels as well, right? So the unit, right, of our decibel power gain is going to be some quantity of decibels. And of course, we know it's going to be positive, right? All right. So, knowing all this fun stuff, in other words, what we've been given and what our goal is, we want to see, well, in order to get our goal, we're going to need a formula that involves our goal. That makes sense, right? We're going to need this groovy little formula, NdB, right? It's the brand new concept for chapter 21, 10 times the log, right? It's always your output power divided by your input power. Always, all right? There's your formula for your decibel gain. And then now it's just a matter of, I hate to say it, but it's kind of plug and chug with a little caveat. In other words, we still need to solve for P in, but once we've got power in, it really is plug and chug because there's our power out, right? And then 10 times the log, your best friend knows how to do that. Bam. All right, so let's go ahead and solve for our one unknown, which is, of course, our input power. All right, so input power, what's the formula? Well, if I know voltage and I know resistance, there's a relationship, right? Vn squared divided by Rn. Bam, let's do a little plug and check here. So I have 180 times 10 to the negative 3. Square that, divide it by Rn. That's going to be 15 times 10 to the, what's kilo? 3. Very good. All right, I hope you're working right along with me, right? So ask yourself these questions. What's milli? Oh, yeah, times 10 to the negative 3. What's kilo? Oh, yeah, that's times 10 to the third. Remember, even though these are pretty easy formulas, you can't touch this easy formula unless you've got the base units of voltage and the base units of resistance. You got to, right? So that said, let's go ahead and head to our best friend and do some crunching. All right, so we're going to do 180. All right, so let me clear this. All right, so 180 blue EE. So important that you're not doing times, 10, caret, right? Don't go through all those steps. Your scientific calculator, regardless of what brand you have, if it's a scientific calculator, straight up, blue EE, or for some brands of best friends, right, some calculators, the keystroke is straight there. In other words, you just hit EE, or you hit EXP, or you hit times 10 to the X. It's a keystroke built right in. What you want to do is find that keystroke. Whatever your best friend is, find out how to get to that times 10 to the. And of course, for 180 millivolts, it's going to be negative 3, right? So 180 e to the negative 3. And then what we're going to do is square it. Okay, so squared. All right, and then we're going to divide that by our resistance, our input resistance, which is going to be 15 blue EE to the 3. There we go. All right, so that's going to be 2.16. Remember, E is times 10 to the negative 6, and what's the units? Watts, right? We just solved for power. V squared divided by R. Vn squared divided by Rn squared gets us power in, right? Power in. So that's what we just solved for. So let's go back and note that down. So our input power, pretty tiny, 2.16 times 10 to the negative 6 watts. All right. And then now for our plug and chug fun, right? So here we are. We've got our formula for our goal, right? Our gain. It's going to be 10 times the log of our output power. That's 24. Note straight up watts, so you don't have it to worry about any EEXP times 10 to the X. Nope. 24 divided by pure watts for your input. That's going to be 2.16 times 10 to the negative 6. And if we work that out on our best friend, in other words, 10 times the log of this, let's see what we get. All right, so we're going to go 10 times the log, right, of 24 divided by, now I'm going to actually bring in my answer here. So second, let's see if I can do that. Second, there we go. And then answer, right, that's my previous answer. Let's see if this works out. Bingo, right, 70.45. What's the units? Always ask yourself that, right? Step back to the real world, right? So here we are just crunching away, you know, doing math. It's like, step out. Now, this is a real world value, right? You have just calculated the gain, right? So it's a positive 70.45 decibels. Bingo. All right, there it is. Don't forget your units. So important. Excellent. So I hope you've had some fun with our Chapter 21 decibel work, and continue working through your problems in Chapter 21. If you've got any questions, by all means, contact me. Also, don't forget, study groups are very powerful. Get together, work through your Chapter 21 exam prep problems. You know, some of these problems are definitely going to take a little bit of time. Put that time in. That's important. And just take your time. You know, really just, give yourself plenty of time. Take lots of breaks and get back into it. But questions, please ask. Keep that communication open. That's key. And have a lot of fun. And I will see you next time. Take care.